Okay, hi guys. We're going to be solving a system of equations using elimination. The last couple weeks we've been solving systems of equations either by graphing or using substitution. And this week we're going to be doing by elimination. So let's talk really quick and remind you about what it means to solve a system of equations. So let's say I have the equation 12x plus 7y equals 29. If I go ahead and graph that, I get this equation. And I'm also going to graph the line 5x minus 7y equals 22. When we talk about solving a systems of equations, we're looking at where those two lines or more intersect each other. And what we find there is we find a solution or a point that is a solution to both of the equations. If it's a point on the blue line, it's a solution to the blue line. If it's a point on the red line, it's a solution to the red line. So right here, this point 3, -1 is a solution to both the blue line and the red line. So it is a solution to the system, okay? So now when I'm finding a solution to the system, I can graph, but there's also other ways we can do it. We can solve algebraically, and that's what we're gonna go over today, how to solve a system using elimination, okay? So let's take a look at these two equations, and we are gonna solve them using elimination. And if you notice, okay, we're going to be using the property of equations that when I add something to one side and I add the same thing to the other side of the equation, my equation stays balanced and nothing changes. So I can either add something to both sides or I could subtract something to both sides. And since both sides of an equation are equal to each other, as in 5x minus 7y is equal to 22, if I add or subtract 5x minus 7y to one side of the equation, it's just as if I added or subtract 22. They are equivalent to each other. So when I'm doing elimination, my goal is to eliminate or cancel out a variable. So when I look here, I see that I have a positive 7y and a minus 7y. Since these are like terms, they can combine through addition or subtraction. And if I add them together, because one is positive and one is negative, if I add these together, they will be 0. 7 plus a negative 7 is 0. So 7y plus a negative 7y will be 0 y's or cancel out. So if I add these two equations together, my y will be eliminated. So let's take a look at that. 12x plus 5x are like terms, and that will add to 17x. 7y plus a negative 7y will be 0y. And 29 plus 22 will be 51. And again, I don't even really need to write a 0y. I can just go ahead and write 17x equals 51. And now I just need to solve for x. So to get my x alone, I'm going to divide both sides by 17. And 17 divided by 17 gives me 1. So 1x is what I have left. And then 51 divided by 17 gives me 3. This is the x value for my point of intersection between these two lines, or the x value to my solution of my systems of equations. Now to find my y value, I just need to take either one of these equations, my top or my bottom one, it doesn't really matter which, and I will be substituting in 3 for x, and I will find my y. So I'm just going to go ahead, I'm going to use the top equation for that, and I'm going to go ahead and I'm going to substitute in to my equation 3 for x, because that's what we found when we combine the equations. Okay, and now I just have to go through and solve for y. 12 times 3 is 36. And then I just need to solve. So I'm going to subtract my 36 to both sides so I can get my y alone. That cancels. 36 minus 36 is 0. And I am left with 7y equals 29 minus 36, or a negative 7. Still need to get my y alone, so I'm going to divide both sides by 7. 7y divided by 7 is 1y, and negative 7 divided by 7 is a negative 1. And there is my point of intersection. It's at an x value of 3 and a y value of -1. Okay, and since this is a location on a graph, I'm going to write my answer as a coordinate point, keeping in mind that our first number is always x and my second number is always y. Okay, and again, I said I could use either equations to find my y value. So just as an example, I could have picked the second equation, and this is like doing a check to really make sure you're right. Okay, I can take my x value and I can substitute that in for x. This is just like if I pretended like I picked the bottom equation. You'll see that no matter which one I use, it's going to come out. 5 times 3 is 15. And then I'm just going to go ahead and solve for y. So I'm going to subtract 15 to both sides. 15 minus 15 is 0. I'm left with a -7y. I have 22 minus 15, that's 7. I'm going to divide both sides by my -7 so that I can get my y alone. -7y, oops, didn't move up. -7y divided by -7 gives me a +1y. And 7 divided by -7 gives me a -1. So you can see no matter which equation I pick, okay, in my system of equations, both of them will get the exact same y value. So when you're solving a system of equations, it doesn't matter which one your second one is when you find your variable. Okay, so that's one example. We're going to look at another one now. Okay, so let's say we have the equation 5x minus 8y equals 30 and 5x plus 11y equals 30. Okay, and I can solve the system of equations, okay, using elimination. I do not need to graph it. So what I do is I notice, I look here and I say, oh my, they both have 5x. Well, if I add that together, 5x plus 5x would be 10x. It won't eliminate. But if I do 5x minus 5x, they will eliminate from each other because 5x minus 5x is 0x. So it is eliminated. Then I have -8y minus a +11y. So a -8 minus an 11. So -8 minus 11 is -19y. And then I have on this side 30 minus 30. 30 minus 30 is 0. And so yeah, that canceled, but I do need something on this side of my equation. So I'm going to fill that in with a 0. Okay, because 30 minus 30 is 0. Now I need to get my y alone. So I'm going to divide both sides by -19. -19y divided by -19 is a +1y. And 0 divided by -19 is 0. Okay, so I found y. Now I need to find x. And just like before, I pick either the top or bottom equation. It doesn't matter which one. I'm going to pick the bottom one because it's all positive numbers in there and less likely to make a mistake with negatives if I do that. And now I'm going to substitute in 0 for y because that's what we just found. And now I just have to go through and solve and simplify. 11 times 0 is 0. So I'm left with 5x plus 0, which really is just the same thing as saying 5x. And now I just have to go through and solve for x. So I'll divide both sides by 5. So that 5x divided by 5 is 1x. And 30 divided by 5 is 6. And I found my point of intersection. Okay, remember the goal was to find where these two equations intersect on a graph. Okay, what point is a solution to both of them? And here's my point. Even though I found y first, I always list my answer as a coordinate point, x, comma, y. So in this case, 6, 0, because this is a location on a graph. It's always x and then y. Okay, so again, on one set of equations I added together and the other set I subtracted together. We're not going to solve these next two all the way, but I want you to look and I want you to see that for these two equations here, sometimes I'm going to add and sometimes I'm going to subtract. And I want you to look at the cases when I'm going to add and when I'm going to subtract. Okay, so here's one set of equations. And then here's going to be another set of equations. Okay, so if I'm looking at these two equations and I want to solve through elimination, I notice they're both in standard form, which makes it pretty easy to use elimination. And I look and I see that both of these have the same number for x. They both have -6. And if I do -6x plus a -6x, I'm going to end up with a -12x. So that wouldn't cancel. But if I do minus -6 minus a -6 is actually going to give me 0. And you might remember a while ago in probably middle school, when you were subtracting and learning integers, if you had something like -6 minus a -6, a lot of times your teacher told you to change your subtraction to addition and change the sign on the next number. So in this case, that would be a +6, and you'd have -6 plus 6, which does equal 0. Okay, and that's the same thing here. If I'm at -6 and I'm taking away a negative, I am going to end up with 0. Okay, and so that's what's happening here. It's a -6 minus a -6. And so that does give me 0. I just need to be careful on my way through that I'm always remembering I'm subtracting. This is not 2 minus 3. This is 2 minus a -3. And 2 minus a -3 is going to give me a positive 5y. If I think about that, changing my subtraction to addition and changing the sign on the other number. Here, this is not -20 plus 9. This is -20 minus a positive 9. So -20 minus 9, okay, is going to give me a -29. Okay, and so as you're going through these, please keep in mind whether you are adding or subtracting things, okay? And that's all I'm going through here. I don't want you to really see the rest of the solving. I just want you to know, am I adding or subtracting? Okay, and again, -6 minus a -6 is what's going to give me 0. If I look here, I have a -6y and a -6y, and I want those to cancel. So I'm going to have to subtract. Okay, 5x minus 7x gives me a -2x. -6 minus a -6 gives me 0. I have -23 minus a -25. It's going to give me a +2. And I could finish solving there. Okay, I want you to look at a couple more equations so we can see if we're adding or subtracting. So let's say I have 3x minus 8y equals 42. And I have a 5x plus 8y equals 18. Okay, if I look at this, I notice my y's have the same number. Okay, just one's positive and one's negative. And so if I, in this case, add my two equations together, -8 plus 8 gives me 0, and that's why I'm adding. Because if I do -8 minus 8, I end up with a -16, and it doesn't cancel. Then I can go through and add everything else. 5x plus 3x gives me 8x, and 42 plus 18 gives me 60. And I can go through and solve for x, and then plug in to solve for y. Okay, so let's take a look at one more equation, and let's look if it's adding or subtracting. Let's say I have -4x minus 5y equals 10, and I have 4x plus 3y equals 15. Okay, so when I'm looking at this, I see my x's in this case are the ones that have the same number, but one is negative and one is positive. So if I add these two equations together, negative 4x plus 4x gives me 0. And so that's why I would add. And then I have negative 5 plus a positive 3y gives me a negative 2y. And 10 plus 15 gives me 25. And then I can go through solve y and then plug back in to solve my x. Okay, so again, we're just looking at times where I'm going to either be subtracting or adding. Okay, so thank you so much. I hope this helps you guys decide whether you should add or subtract the two equations together, and also how to take your next steps in finding the other variable as well as doing a check if necessary. Okay, thanks guys. Hope to see you guys soon on one of our Zoom calls. Bye guys.